Okay, before we jump into complicated problems with x's and stuff in them, variables in them, let's look at just some basic fractions and how to add and subtract them first. I realize some of you are fine with this. If you want to just watch and remember, it's up to you. If you feel like you need to write it down to remember it later, that's fine too. But the main thing you do when you add and subtract fractions or rational expressions is that you must have a common denominator. And then once you have a common denominator, you can add or subtract the numerators as it tells you to do. Okay, so let's just refresh our memories on this process by just taking a basic problem here. So let's do 3/5 minus 2/7. So do we just go 3 minus 2 and 5 minus 7? No. First of all, they don't have a common denominator. So that's the first step, is to get a common denominator. So in this case, since both 5 and 7 don't have any factors in common, they are separate prime numbers, we actually just find the common denominator by multiplying them together. So that will mean that this fraction will need an extra 7 multiplied in, right? And this one will need 5. So we can multiply by 7/7 on that one, because we're basically just multiplying by 1, and 1 doesn't change anything. And then on this one we can multiply by 5/5, again multiplying by 1, which doesn't change any values of the fractions. Okay, so then we have 21/35 minus 10/35. So we now have a common denominator, so now we just add or subtract the numerators. This one is subtract. So 21 minus 10 is 11. Now the last step you should always consider, but just heads up on your homework, there's not very many that you even need to worry about this on. But the last step you should always consider is that this might reduce. So does 11/35 reduce? No, it doesn't. Okay. So what were the steps that we just followed? What did we do first? Okay, so we identified what the common denominator needed to be, right? Identify, I can't spell. Identify, there we go. Common denominator. Okay. Another name that sometimes we call the common denominator is a least common multiple. Have you heard that before? So basically that means it's the smallest number that both denominators divide into. Smallest number that all, we could say both, but sometimes there's more than one. Not on your assignment, but sometimes. Okay, so for example, did we have to use 35 or could we have used 70? We could have used 70 because both 5 and 7 divide into 70. That would be a common denominator, but that wouldn't be the least common denominator. Using the least common denominator helps you from having to reduce it later. Although sometimes you still have to reduce it later, but it helps so that it's less often. Okay? Alright, so step 1, identify the common denominator, which is also called the least common multiple, which is the smallest number that all denominators divide into. Okay? Then we will multiply each fraction, sometimes a rational expression, I'm just going to call them fractions, it's easier that way. Multiply each fraction by the number that is missing in the denominator. So, for example, in the problem we just did, it had a 5 when we found out the common denominator was 35. That meant it was missing 7. So we multiplied by 7. This one had a 7, but the common denominator was 35, which meant it was missing 5. So we multiplied by 5, right? Okay. Step 3, you have your common denominators, so you just add or subtract the numerators. We kind of already said that. Just combine like terms. And then step 4 is reduce if needed. If you don't even need to write these steps down because you remember all this and you're good at it, then not a big deal. Up to you. But it might be helpful as you get into more complicated problems and you start forgetting what you're supposed to be doing, to have a list of steps to look at and know what you're trying to do. Okay, so let's look at a more complicated problem. Actually, I'm going to start with one that's not too bad. Sorry. And then we'll do a complicated one. So, example number 1. Can I move this up? How far can I move it? Is that too far? Okay, let me know if you need to see that again. Let's add n over n squared plus 4n plus 4 plus 2 over n squared plus 4n plus 4. Okay, step 1. Identify the common denominator. And frequently you have to factor to be able to do that. But in this case, what do you notice? They are already the same. So we identified it. There it is. Now we multiply by whatever's missing. Anything missing? Nope, because it's already common. So we get to skip steps 1 and 2 basically. Which is nice because that makes this really easy. Step 3. So we're just going to combine like terms if we can. We can't because they're different, so we just add them together. And then here's the denominator, n squared plus 4n plus 4. Now what? Reduce if possible. So before we can reduce them, we always need to factor and see if there's any common factors. Can we factor the denominator? We just practiced that on our self-starter a bit. N plus 2 and n plus 2, which technically could be written as n plus 2 squared. But I don't want to because I'm just going to cancel one of those. What's my final answer going to be? What's on the top of our fraction? Okay, is nothing 0? Ah, nothing is 1. 1's not really nothing. Because remember, when you reduce, you're dividing these and so they equal 1, right? So we end up with 1 left in the numerator and n plus 2 in the denominator, and there's our final answer. Now, could either of these simplified before they were added together? No, because you cannot cancel terms, you can only cancel factors. So before they were added together, they could not simplify. However, once they were added together, we were able to simplify and make it nicer, right? Okay, let's do another one before I give you a chance to try some on your own. Let's do it harder, yeah, not hardest, but harder. Alright, step 1. Let's find the least common denominator. Anybody know what it'll be?
14.
I was afraid someone would say that.
Wait. Is it?
What's the least common denominator?
Give me a second.
Okay, let's think about this for a minute. This is a number in disguise. And this is a different number in disguise. The reason I call them in disguise is because they have a variable there that we don't know the value of. However, if we know the value of that variable, then we would have this as a number, and this would be a number. Well, earlier today, we did a problem very similar to this, where we had a number and a totally different number. What did we do with those two numbers? We just multiplied them together. So these are two completely different numbers. The least common denominator is found just by adding those two completely different values together. Multiplying, yes. So I'm actually not going to FOIL it like has been suggested, at least not yet. I might do that in the last step. But right now I'm just going to leave them next to each other. Does that still mean multiply? Yeah, it does. I'm just not simplifying it yet. Okay? So our least common denominator is m plus 2, m minus 7. Okay, so step 2. What is this fraction missing? M minus 7, correct? So we multiply by m minus 7 over m minus 7 because that's a value of 1 and it doesn't change the values of the fractions. What are we going to multiply this fraction by? M plus 2 and m plus 2. Does that give me my common denominator in the bottom? It does, okay? But in the numerator, I'm going to have to distribute. So let's go ahead and distribute 9 times m, 9 times 7, 8 times m, 8 times 2. So we end up with 9m minus 63 over m minus 7, m plus 2, plus 8 times m plus 8 times 2 over m minus 7, m plus 2. Okay, there's step 2, all done. What's step 3? Combine them together. So, any like terms we can combine? 9m and 8m equals 17m. And then what's negative 63 and 16? Negative 47. Now, I'm trying to look ahead to see if this will reduce. Is there anything that can be factored out of that to make this look like m minus 7 or m plus 2? No. So since I know that none of these are going to cancel out anyway, at this point you could either just leave your denominator as m minus 7 parentheses m plus 2, or you could go ahead and FOIL now. Okay? So m times m is m squared. M times 2 and negative 7 times m will give us a negative 5m in the middle. And then negative 7 times positive 2 is negative 14. So there was a negative 14 in there. Okay? But negative 14 was just a teeny tiny part of that least common denominator. Okay, do you want to see another one that might be a little harder? Or do you want to try one on your own? Try one.